Namaste student. Today we are going to see a new topic, that is a polygon. What is polygon? So let's see here. Poly means many, gun, sides, angle. Okay. Let's see. Here a simple closed rectilinear curve is called polygon. And if you see the types, triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon. So let's see. Three-sided polygon is called triangle. You can see that three-sided. You can see four-sided polygon is called quadrilateral. Five-sided, 1, 2, 3, 4, 5. Five-sided polygon is called pentagon. Six-sided polygon is called hexagon. Seven-sided polygon, heptagon. Eight-sided polygon, octagon. Nine-sided polygon, nonagon. And 10-sided polygon, decagon. There is many, and decagon, dodecagon are there. We will not discuss that many. Only we have 10 in our syllabus. Let's see. Now, question will arise: what is polygon? Here already written, but could not understand. Sir, what is this? A simple closed. So if you see here, there are terms. How many terms? Simple, closed, rectilinear, curve. So let's see one by one. What are your curve? First we'll see from here curve, and then rectilinear, and then closed, and we'll go for simple also. These are the compact form. These all are different terms, and we'll try to understand when each compact form will be in a particular case. Then that particular case have a special name called polygon. So let's see each term separately and try to understand what are these. Okay, so these are the time. You can see the time. Okay, now we go for first curve. What is curve, sir? The curve and continuous flow. This is your curve. It may be a straight curve, and that has a special name. If the curve is straight, then we call what? Straight line. Or line segment. If it is stop, it has a what? Two end, then it is a line segment. Okay. Curve. Now curve. Maybe this, maybe that. So when curve is a straight, follow straight path, straight line, then that type of rectilinear curve. Remember, this is your rectilinear curve. Have you seen? Straight and sharp corner. You can see there is a sharp corner. This type of what? Or you take this one, rectilinear curve. If you see this S, C, U, if you go for the V, this is rectilinear, and U, C, S, this type of curve is non-rectilinear curve. Okay. Now, if you see that after that, so I think that you have got the what is rectilinear. Okay. Now, if you proceed for simple, so what is simple? Like if I take that is normal curve and if I close it, what we call this one? So if we will take this one, then it is your circle and it is simply called simple curve. Why? Let's take one more example. Simple. Okay, simple curve and what you know? See, initial point and the final, starting and ending point meet at a point, common point meet. Then this type of figure is called closed. If I take this one, if we start from here, go and join. So you can see here, starting and ending meeting. So this is closed and this is also closed. This is your rectilinear closed curve, and this is non-rectilinear closed curve. And one more thing, it is your rectilinear closed and simple, and this is your what? Non-rectilinear closed and simple. Now question will ask, so which is not simple? That one we call complex curve. So if you take not simple one. So let's see the not simple one like this. This is closed, but if you see here, we have here one intersecting. You can see the curve intersect by itself only. This type of curve, and which is closed, you can see the closed also. Then this is what complex, non-rectilinear, closed curve. See, first it is complex. Why is it complex? Because you can see one intersecting. It may be more than that. Like if you take this one. See, if you take this one, I have started from here. One intersecting points. So this one have a special name. We call node, N-O-D-E, node. 1, 2, 3. There are 3 nodes. And look at starting point here, ending point here. Then this is what. First you can see that it is your what? Complex. After that, non-rectilinear. Why? Because there is no line segment. Okay. There is no line segment. That is what? Non-rectilinear. And you can see that it is not closed. That means what? Complex, non-rectilinear, open curve. It is open curve. Remember, which are not closed. That is called open curve. Now, if I take this one and also join here, then it is what? Complex, what? Non-rectilinear, closed curve. It should be closed. Okay. Now, if I take this one, you can see starting here and again ending here, and you can see these are what? Line segment, and there is a node. That means what? This one is what? This is your closed. Yes. This is rectilinear. Yes. Okay. Next, is it simple? No. Complex is not simple. Next word. It is closed curve. Yes, closed curve. It is rectilinear curve. Yes, it is rectilinear curve. It is open. No, it is not. Already we have told that is a closed curve, so we cannot say open curve. And you can see that it is closed only. So this type of figure, if you have a node, we call what? Complex. It is not your simple. So we cannot say this type of figure as a polygon. You cannot say. Okay. Now if I take like this come and show. Can you guess what type of figure is this? So it's starting from here, going and again coming here. So we are reading here closed. Shall I say closed figure? No, you cannot say. Why? This is your starting and ending is here. And look at here, they are not joining. If they are not joined, then this is what? Open. Now it is rectilinear. Yes, it is rectilinear. You can see the line segment. Each part of this will see. This is one part, another part, this is another part. These all are line segment, made up of line segment. If a little bit curve, see, if I take a little curve like this, so can I say this is your rectilinear? No, you cannot say, because you can see the little part is also a curve. So you cannot say but curve means we are bending, so you cannot say rectilinear. Okay, right now we have taken, this is your what? Complex. Okay, is it closed? No, it is open. Next, it is rectilinear. Yes, it is rectilinear. So this is also not polygon. Polygon is this one. Why? This is your simple. There is no node. Simple, closed, rectilinear curve. This type of figure is called polygon. These are there, but we don't have this all in our syllabus. But you have to know about this all. And this one you need to see separate chapter. Circle is there in our syllabus. Okay, we'll discuss this one later. But we go through this one, you can see. But you can see that simple closed rectilinear curve is called what? Polygon. I hope you people have understood. So let's take more examples so that it will be more clear to you people. Okay, like so if you look at this figure, so can you guess what type of figure is this? Yes, if you see that all are what? Line segment, made of line segment. That means first it is, okay, first we'll take it is what, simple or complex. It is complex. Okay. Why is that? Because intersecting point you can see 1, 2, at least one intersecting point if you see, it is complex. There should not be any intersecting point. Next, is it closed? No. You can see that starting point we are starting here, we are ending here. It is not closed. So we call here open. Next, is it rectilinear? Yes, it is rectilinear. Okay. And if I join like this, if I bring it here, join it. Can you give the name of this figure? Yes. Complex, but it should be what? Closed, rectilinear curve. This one. Okay. I hope you people have understood what is polygon. Okay. Thank you. Now we are going to see that types of polygon, and in that angles, side, vertices, and how to find adjacent side. Okay, adjacent angle. Let's one by one. So if we'll take triangle, first one. So if you see this one, give a name A, B, C. Then if you see, look at this one or this one, line segment. These are line segment. So if I take this line segment, we call sides. So sides of polygon, this is your triangle. So side, how are we going to give? AB. Generally we use alphabet way. That means A, B, C, and C. You may say that, sir, if I give a name AC, is there any mistake? No mistake. If you give a name AB as a BA, is there any mistake? No mistake. Okay, you can take, no problem. So these are your sides. There are three sides. And angle, you can see the angle. So angle representation, how will you use? Angle A. This is the A. Angle B, angle B, and this is your angle C. This way we can represent. After that, if you take as this one, A is called vertices. Vertices means you can see that two what? Common point, most common intersecting point of two line segment. This is one line segment and this is a line segment, and they are meeting at a common point, and that common point have a special name called vertex. Is a singular form. Vertices is a plural form. So how are we going to represent here vertices? A, B, C. This way we are going to represent. So is there any diagonal? No, there's no diagonal. We'll try to understand what is diagonal. Okay. And diagonal will start with the quadrilateral. Okay, there is no diagonal in this case. We're going to see. Now, adjacent side. Okay, how are we going to represent adjacent side? So let's see. If I'll ask you adjacent side of AB, what will be the adjacent side of AB? मतलब बगल वाला AB का बगल में कौन कौन है? Adjacent side. तो आप देख सकते हैं AB को अगर आप लेते हैं तो उनके बगल में AC भी है, BC भी है. तो आप AB, BC लिख सकते हैं और फिर AB, AC भी लिख सकते हैं. और फिर अगर आप adjacent side देखते हैं तो BC, AC का adjacent है. तो you can write like this: BC, AC. So these are your adjacent side. Similarly, if you see the adjacent vertex, that means A and B are adjacent. A, C are adjacent, or B, C are adjacent. Okay. So adjacent side, you can take as adjacent angle also. So right now we go for diagonal, and then we're going to see your adjacent side for quadrilateral. Okay. So let's go for quadrilateral, and then we'll try to understand what is diagonal. So if you see diagonal, so what is diagonal? Diagonal. Join, okay, by two non-adjacent vertex. The line segment joining by two non-adjacent vertex, yeah, vertices. So if I take A, B, C, D, and if we see here A adjacent is what? B. This is take as a vertex. Okay, we'll go for vertex point we are taking. So A adjacent is B. A adjacent is what? D. So leave these two, which are not adjacent. Which one? C is not adjacent. Join it. So this line is called what? Diagonal. Similarly, if you look this one and this one, they are not adjacent vertices. That means if you join them and whatever line you are getting, that is diagonal. There are two diagonal in quadrilateral. Okay, we go for pentagon and we'll try to understand how to find diagonal for pentagon and how many diagonal are there. Okay, let's see. If you look at here A, B is adjacent and E is also adjacent to A. So we'll now look at B and E. Okay. Now we're going to see what. Wait for a while. Now, if you see here, C and D are not adjacent to your A. Now you join it. If you join A to C, one diagonal. A to D is another diagonal. So two diagonal we have already got. Now you go for your B. So if you look at the B, point B, adjacent to B is what? A, adjacent to B is C. And forget about C and A. Now let's check for which are not adjacent. B is not adjacent, so join it. B. So BD is your diagonal. And if you look at here, E is also not adjacent to your B. And if you join it, BE, this is also we call diagonal. This way we need to find diagonal. Is there any more? Yes, if you go for C, adjacent to C is what? B and D. A is not adjacent and what? E is not adjacent. That means we are going to join this one. We have already joined. So AC you say or CA you say, both are same. Okay, any one of them you need to read it, AC or CA. And look at here, we have not joined that one. So CE we have joined. Now can you guess how many diagonals are there in pentagon? Similarly, you need to find your hexagon. This is your hexagon, six-sided polygon. It's called hexagon. It's not line exactly or 5 check it, six-sided. That means if you go for hexagon, 6 angle, okay, 6 side, 6 vertex, you can say. But diagonal will not be 6, more than that. Let's count. If you go for this one, you grab A, B, C, D, E, F. And if you look at here, if I take A, AC, AD, A, first, next, BD, BE, BF. Next, if you proceed for C, CE, CF, A, CA already we have drawn. If you go for D, D is already this one, we have this one, BD already we have, DA is already we have, DF. Now if you go for E, yes, already we have drawn. So this many diagonals are there. Okay, I hope you have understood how to find diagonal and which are your adjacent angle, adjacent side and adjacent vertices. Thank you. Thank you all.